SN1 or unimolecular nucleophilic substitution reaction. As is clear from the title, it's a nucleophilic substitution, and rate of reaction is proportional to concentration of one molecule. That is why it is unimolecular. Now let's take an example. Rx plus OH minus, it gives you ROH plus X minus. We can write this also as, let's say we have, this is tertiary butyl bromide plus OH minus gives you tertiary butyl alcohol plus X minus. Now let's look at the mechanism of this reaction. What happens is, in the first step, which is also the rate determining step, and it is a slow step. The rate determining step is always the slowest. In this step, the alkyl halide or the tertiary butyl bromide, it breaks up into carbocation or tertiary butyl cation plus Br minus. Now you know the stability of the carbocation is tertiary carbocation is more stable than secondary carbocation is more stable. Tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation, and methyl carbocation is the least stable. Okay, so in this step or the SN1 reaction, its rate is faster for the tertiary carbocation because it's the most stable. Now once this tertiary carbocation has been formed, the second step is this tertiary carbocation is attacked by the nucleophile, which can be OH minus, it can be any other nucleophile also. Now this attack is on the left as well as front side of the carbocation. So if it attacks on the left hand side, or the right hand side, the product is tertiary butyl alcohol. This is the product. And if it attacks on the left hand side, the product is this is the product. So you get both the enantiomers. You can get R and S both enantiomers. Okay, and there is no inversion of configuration. But yes, if it attacks from the opposite side, they might be, but not necessarily, which is a rule in SN2 reaction. So that there's no necessarily inversion of configuration. They may be, they might not be. If it is attacking from the opposite side, they might be, but not necessarily. Fine. Now, one thing I forgot to tell you was that this carbocation, this is sp2 hybridized, and because it is sp2 hybridized, the OH minus ion, it can attack from, as I said, from both sides, leading to the formation of the two enantiomers. Now, so we can say rate of the reaction, it is proportional to the carbocation, or you can also say the rate of reaction is proportional to the alkyl halide, because the alkyl halide gives way to the carbocation. So you can say rate is equal to K into Rx. So this was nucleophilic substitution unimolecular reaction. One thing more I forgot to tell you was that the rate of reaction also depends on it is fastest for Ri, because in Ri the iodide ion being larger in size will easily break up. Alkyl halide will easily break up, then RBr, then RCl, and the slowest for RF, because this is very difficult to break. The cleavage of this bond RF is very difficult.